Okay, so Simona,
Hi, everybody.
hi. Hi, Simona. First of all, welcome to our meet. We're excited to see you here. We are also live on YouTube, so I hope that everyone who watches this will get some sense of the importance of technology in STEM education.
Sure. So it's an absolute pleasure to be here. I have to apologize up front that the camera on my personal computer doesn't work. I tried to see if there's any settings, but I think I actually broke it. So we will have to do without video, unfortunately.
It's fine. Your words really matter.
Okay. So welcome everybody. Again, thanks for the invitation. It was actually really nice to have Elisa reach out and ask that if I may speak at this event and to give a glimpse to colleagues and in general people that are interested in technology. The technology that I'll be speaking a bit today is space technology. So maybe a bit of background how of where I started and how I ended up working at OHB in Germany. This is a company that is called a large system integrator. And long story short, we basically build satellites, various spacecraft, planet or asteroid probes, and then we work with suppliers like SpaceX, and of course in conjunction with NASA or ESA, in order to get the product to its final destination. And the one that I'm going to be talking about today is Hera, which is an asteroid probe, but I'll get back to that in more detail later. So, of course, first off, feel free to interrupt me at any time if you have questions. And if not, then we can talk, we can discuss about them at the end of the speech. I'll try to keep the introduction short and then get to the good stuff. So, I have graduated from Decebal in 2011. I see that also Mr. Stanculescu is here. Hello, sir. Um, Mrs. Stanculescu has been my physics teacher, and actually she has kept my motivation up to pursue a career that has to do with engineering, not necessarily physics, because at that point, to be completely honest, I felt that it was way beyond my capabilities. But then we will see how it's not such a good idea to have such thoughts, especially at such a young age, because you never know what you could actually accomplish. And if you stop yourself short and say, okay, this is not for me, I need to find something else, then who knows how many chances you might miss. So I did mathematics informatics until 2011, and after I graduated, I really wanted to pursue computer engineering, software engineering in particular. So I went to study at Timișoara. I got at the Polytechnic University. I got my bachelor's degree in 2015 and then a master's degree in software engineering in 2017. I began my software engineering career by working at Continental. It was like the first job. And after a few years, I started thinking, okay, this is interesting. Everything there's so many applicabilities for software in absolutely every industry. And then I started thinking about the fact that I am a huge Stargate fan. So ever since even before high school, I used to watch the series, and I honestly thought, okay, working in with space related stuff, is probably the coolest thing that it could probably do, at least for me. So after a few years in the automotive industry, I decided to try to give it a shot and find a software engineering position in the space industry. And this is how I got at OHB in 2018. And yeah, the thing is that what message I would like to give to everybody today is, if you really want to work with a particular technology or in a certain industry, just try to go for it. So there's so many possibilities. And at first I was rather intimidated by the idea that I did not know anything space related. I did not know any communication interfaces or units that go into a satellite. So when going to the interview there, I was thinking to myself, okay, it's worth a shot. I don't think I have too much of a chance anyway. But actually, the interview went so well that they almost instantly told me I was hired. And fast forward into the future, now I got to see just how many possibilities there are out there, how many things you can do and to discover. And this project that I would like to talk to you about is basically a spacecraft, a probe. No, let's backtrack. I don't know how many of you remember, but in November 2022, NASA sent a probe to an asteroid called Didymos. The probe was called DART, and the intent was that this probe gets to the asteroid and then basically slams into the asteroid as hard as it can in order to change the asteroid's trajectory. So this happened 2 years ago, and the Hera project is the second part of the scientific mission. And the purpose is to fly again to Didymos and to see how the DART probe has impacted the asteroid. Did it change the direction in which it was flying? Did it alter its entire structure? So scientists currently say that the asteroid is completely changed. So the impact was so strong that they managed to actually change the surface of the asteroid quite significantly. And all of this is completely international collaboration. So it has been super motivating and inspiring to see how engineers from NASA, ESA, even JAXA, so the Japanese space agency, are working together towards the same goal of learning how we can keep Earth safe from space. Yeah. So there. First off, any questions so far or remarks?
From which type of, like, the Polytechnic University of Timișoara, which was your specialization?
So I don't know exactly how it is today, but there was this automation and computers faculty. So I went to that one, and I think in the beginning, everybody is put together in the first year. So the curricula is common, and then you get split into 50-50 between automation and computers, and I went for computers. I think it's in Romanian was Calculatoare și Tehnologia Informației, CTI.
Yeah, we still have that, so thank you.
Okay, cool. So highly recommended. Then what else? Yeah, who here is anybody here that is very interested in joining the space industry, maybe in the future? Yes, please go ahead.
Well, I'm also I'm interested in sort of robotics involved in space exploration because I want to sort of future in that field, and space has always fascinated me. So, yeah, I was wondering if you have any insight on how robotics could be used in the future.
Oh, so I'm sure you're familiar with a lot of the robots that have been sent to Mars. One of them was also so OHB itself was also working on ExoMars. But unfortunately, if I remember correctly, this mission was canceled due to, or put on hold due to the conflicts that have arisen in the past year. But yeah, robotics could actually has a very high applicability. So, for example, what do we do on a day-to-day basis when you want to build a spacecraft? The process is extremely long. So, for example, if me coming from pure software position, I expected that every project takes, let's say, 1 year, 2 years. No, if, for example, if you start in a satellite project from the beginning, or more or less from the proposal phase, and you want to see it through completely, expect that you will be in that project for at least 6 to 8 years at best. And a big part of this process is the assembly of the spacecraft itself. So we buy a lot of units, or we make the units ourselves, depends on the company. For example, I think Airbus also makes some of their own units. And then you have mechanical and electrical assembly and integration testing engineers, the short AIT. They are basically responsible with assembling everything. And what would be extremely cool in the future would be to maybe figure out a way how to speed up this process by having the engineers not build the spacecrafts themselves, but to teach robots how to build them themselves. So sorry?
If I'm not mistaken, like, let's say, for example, ET, like, I think it's the first interaction of a kid with robotics in space. And I know this sounds very childish, but I think, if I'm not mistaken, it has those, not necessarily wheels, but you know what I'm talking about. It was way to go through.
To go around, yeah.
Yeah.
I think it has those tiny wheels like on a tank, if I remember correctly, in
Yes.
a triangle shaped.
Yeah, so I just wanted to say that we also have that in some robots, on some robots in our competition, and related to what Raul, our colleague, said, who's interested in robotics in the space industry. This is part of our competition, like to solve problems encountered in real life situations. And so, yes, just go on. I would just want to bring this into the equation so that maybe the kids who are here will get a better understanding of robotics in space.
Okay, understood. Thank you. What else could it be? Robots in space. I think currently the industry is undergoing an interesting shift. So, for example, in the past, it used to be the case that everybody that wanted a satellite, be it a telecom satellite, a science satellite, they were all pretty huge. So when we are talking about one of these, you can easily imagine a really huge 6 meter tall monster that weighs 1 ton. maybe even more. And this currently, so assembling, having the need to assemble such huge satellites is a big problem, because when you want to launch them into space, the cost of your launch is calculated per kilogram, and then the bigger, even if your payload is not so huge, if overall the spacecraft weighs a lot, then you will suffer a lot for regarding the costs for the launch. And even though SpaceX has brought down the cost of a launch, so for example, Ariane from Europe, if I remember correctly, an example, the cost of a launch was a minimum of 100 million euros or something like this. And SpaceX has managed to bring this price down, but it's still in the lines of tens of millions. So it's very, very expensive. And in the last 5 years, roughly, the industry has taken a huge interest in small satellites. A lot of them are just directly called CubeSats, because they're very much a cube and they are quite small. I think they all weigh something like 5, 10, 15 kilos. I'm not sure if more than this. And they are an easy way to bring things in space. For example, if for all of you interested, I would recommend searching for institutions or groups that offer students the chance to work on developing a CubeSat. Because, for example, if you partake in such a challenge, and your project wins, most of the times the institution will actually launch your CubeSat into space and see if it functions, or if it withstands the launch, and your designs were correct. So I highly recommend this. There's so many activities. And also ESA is trying to encourage as much as possible more, so as much involvement from people, especially students. If you are interested in seeing and learning about a lot about these missions, you have every year I wouldn't call it a conference. It's more like a yearly event. It's called ESA Open Days. Almost always happens in the beginning of October, and you can sign up. It's free to join the event, and there you have a lot of speakers and presenters that show you a glimpse into some of the projects. So, for example, I went last year, and there was a very nice presentation on the James Webb Telescope by someone who actually worked on it directly.
And so you mentioned that we should, if we want to go into the space industry, we should look for universities that have the in their program the launch of a CubeSat. Do you happen to know any universities who are involved in activities like such? Like,
unfortunately, not off the top of my head, but we are in contact, so I can easily send you a list. So I'll make up some things. I remember also hearing from colleagues that there are such competitions, not only the CubeSats competitions, but also rocket building competitions. One of my current team members, before I hired him, he participated in such a competition, and they won. They managed to make the most stable, I think it was 1.5 meter rocket that actually managed to fly the farthest into the air.
okay, so practically we should look for real life applications of these subjects.
Yes.
Thank you.
Yes, welcome. Give me just a few seconds to note down that I shall send you a list with such examples. Okay.
We will also make it public on our social media accounts so that children and not only adults, anyone interested, will be able to see the outcome of our meet.
Mm-hmm. Oh, that would be awesome. That would be awesome. So yeah, what else I can tell you about the project? How I ended up working on it. So I'm actually surprised myself that I ended up working on it. So, for example, if someone would tell me 8-9 years ago that in the future I am going to actually collaborate with ESA and SpaceX in sending a probe to an asteroid in order to figure out how to defend Earth in the future, I would just laugh and say, yeah, in my dreams, that's not gonna happen. But it's not so unapproachable as one might think. So now I think most of us, so for example, I don't know how many of you intend to, if you're highly interested in space, of course the natural step is to then go to the Aerospace University in Bucharest. But for example, let's say that you can't do that, or you don't decide to do that, and then in the future you still want to join to work in space projects. You never know how. So don't let yourself don't let yourselves be intimidated by the fact that, oh, it's a space industry. There's only rocket scientists, and you need 3 PhDs in order to work on these projects. Everything can be learned. Due to the nature of the projects, they are so special that you don't really learn how to work in these projects, and almost in no university. I know I have many colleagues that have graduated from the aerospace industry, and they do learn a lot of things in theory, but it's completely different the moment that you go to your test model and start assembling all of the units, do the electrical testing, and then have some other team build a software that then you have to use in order to operate the spacecraft.
So there's hope even for those who don't graduate such universities like Aerospace in Bucharest.
Exactly.
Noted.
Yeah, do you want to say something?
Yes, hello.
Hi.
I might ask, what were your biggest struggles after graduating college, and what were the biggest challenges you expected in your journey?
The biggest challenges in general, or moving in this industry?
Yeah, moving in the industry.
Moving in the industry. So I think at first, let me think a second. I saw a very huge difference, for example, in the way we handle this in Romania versus Germany, for example. So in Germany, most of the colleagues haven't actually worked during their university years. And this is something that is quite happens quite often in Romania. So, for example, I started studying at the Polytechnic in September 2011, and I got my first job as a C++ developer in 2000. Let me think. 2012, no, 2013. And so in my second year of university, second semester, and this actually helped me immensely, because as much as I learned in a highly contained, highly idealized environment at the university, when you have to work on a very specific real life project, there are some things that maybe you can apply or maybe you cannot apply what you learn, because circumstances completely vary. So for me, this was an incredibly huge help, that I started working, well, in the automotive industry at first while I was studying. And then I could see, okay, I learned how to do something in this way, but in a real life project, due to some circumstances that you cannot teach this, you cannot learn it, because it just completely depends from project to project. Then you see, I have to actually adapt the way I work to this. And for joining the space industry, I think my biggest challenge was to actually completely learn everything that is being used in this industry. So coming from automotive, I knew, so I always worked with low-level software, which was a huge plus, because if I coded for something that goes in a car, or I coded for a processor in a satellite, it's not that big of a difference. And the only thing that was missing was that I had no idea how a star tracker works. We suddenly did not have Intel CPUs running Linux. We had very special processors that are being used in this industry. You can only work with certain operating systems for now, although this is changing. And I had to basically forget a lot of the things that I learned in order to work in the automotive industry, and start learning a lot of new stuff to be able to work in the space industry. So yeah. Then what else? Then so I will prepare the list with the competitions. What I wanted to say is Hera is currently undergoing, environmental tests. This is also something very interesting with respect to satellites versus other objects, manufactured objects like cars. Before you are able to actually launch a spacecraft in orbit or in deep space, wherever it has to go, it has to go through very particular environmental tests, because you assemble something that then has to withstand the vibrations and the shock of being launched in a rocket. And then, of course, once it reaches space, it will be subjected. So everything that faces away from the sun is facing the deep space, and can easily, so very quickly, get very, very, very cold. And everything that is facing the sun heats up very fast. And in making sure that you can actually launch your satellite into space, you have to make sure that your spacecraft can withstand this extreme environment. So there are actual companies, I wouldn't say companies, institutions. There's also a company and also an institution that provides such environmental test chambers. In short, in the space industry, people generally call it TVAC, thermal vacuum tests. This is one of them. not the only one. So for example, also the shaking. So the spacecraft is actually put on a shaker, and it's shook so much as possible to simulate the launch of the rocket. And then there is a pressurized chamber where we can put the spacecraft, and then you remove the pressure and take it through heat and cold cycles in order to see that all of the units are well prepared to function in space. And Hera is actually exactly in this phase. We are working on finishing the environmental tests, because the launch is October the 7th this year. And you will be able to see, I'm pretty sure ESA is definitely going to provide videos and coverage of the event. SpaceX as well. We are launching the spacecraft with SpaceX. And then it's going to be a rather long journey to the Didymos binary asteroid, because it takes roughly 2 years to get to it.
And just a question. I'm not an expert in the domain, but how many others prompts have been sent out into space in order to do what Hera is about to do? I mean, 2 years just to reach the asteroid is a lot, in my opinion.
Yeah, that's true. I think almost everybody knows the very longest running one so far is Voyager 1 and 2 are also probes, and they have been launched in the 70s. I'm not sure about the status of Voyager 2, but I think Voyager 1 has managed to exit the solar system completely. So it's so far away. What is that? Roughly like millions of kilometers so far, which is completely mind-blowing, because I personally cannot even imagine how much 1 million kilometers actually is.
And I mean,
sorry?
No, sorry, continue. I will.
No, good. There have been quite a few. So in general, anything that does not stabilize in an orbit around the Earth or any other planet, we then just call a probe. I think also, which one was the last one launched this year? I think it was JUICE. Again, an ESA project launched to, I think, to investigate either Jupiter or Saturn. I should have looked this up. Also a very interesting project. They have quite an advanced and complex scientific payload. And yeah, there's quite a few. There's quite a few launched already.
Thank you. Thank you.
Jad, please go on.
Hello, I would also have another question about education and how it affects you on your like future. How much did high school get I don't know how to say it, but how much did high school help you in life with your future? You know?
Actually, high school is exactly when I realized that I wanted to do engineering. So it was actually pretty interesting. I don't remember exactly why, but until the 9th grade, I was very, very, very convinced that I wanted to study English. I really don't remember why, but I was very excited to know and to be able to speak English as well as possible. And then I started programming computers. So, and also at that time it was quite it wasn't really anything you would actually use in the industry. So we used Pascal. And ultimately, I think we also did C++ or C#, I don't remember. But being introduced to to this domain, let's say, to software development, has made me realize that no, I actually really want to do this in the future, and to write software for different electronics, learn how these electronics work, and has completely changed my perspective of what I want to do in the future. And at the same time, since I was also a huge Stargate fan, I think this also kicked in a bit more. I think in general, school in general, so also high school and university, has helped me learn, so hear new things, because what happens is you grow up. So students, when you're a student or when you're a pupil at high school, you're very young. You have barely heard about maybe 0.0000001% of the things that exist on this planet, or what the people are doing. You have, for example, if you really like, I don't know, chemistry, for example, maybe you will know something about electrical engineering, or you learn something about the electrical engineering as well, but you will never know anything about aviation. So, and then the purpose, what I try to do through high school and university, is learn about as many new things as possible. So not studying them in detail, but just be aware of them. Because if you are not aware of your possibilities for the future, then you will maybe not be able to find what you are very passionate about.
Okay, so maybe that's why we need more extracurricular activities in high school, so that pupils will get hold of what they might want to do in the future by trying out new things.
Exactly.
Okay.
I strongly encourage this, and it's I mean, of course that you will do some things and say, okay, this is not for me, but then at least you know what you don't like to do, and it's completely changes your perspective the moment that you find something, or you accidentally read an article or read a book or go to a conference, work on a specific on a new topic with a new teacher or new colleagues, and then you suddenly find that thing that keeps you very interested for quite a long time, and then you know what you want to do in the future.
Okay, that's also what we are trying to do. Like that's literally our motto. Like to try out new things, even if you don't like them, just try.
Just try. Yeah, exactly. That's an excellent motto, because you don't know what you like until you try it.
If I'm not mistaken, we also have passions about space in school, and again, if I'm not mistaken, they used to have a club, but unfortunately there weren't many people, so I think it's no longer operating, which is quite sad, and I think we should try to solve that. We should try to revive it.
That's a good idea.
And so a question that I want to ask you, and now I remembered it. Taking into consideration the way things are moving, and I think that things are moving at a very high speed. How do you think that the industry, the space industry, and especially what you're doing there, will look like in 10 years' time, let's say?
In 10 years' time, and me saying, it will be very. I'm super excited about what the future holds, because the equipment is getting less and less expensive. The time to produce such things, even though it's still rather complex, is also reducing, and there is a general desire to also learn how to do certain things in space. So, for example, one of ESA's biggest topics for the future is how to manufacture various things in space. For example, using additive manufacturing, or how to assemble things. So, for example, I spoke about how building very large spacecraft is very complicated and very costly, and also very risky, so to say, because when you do the shaking test, so to simulate like you're in the rocket and the rocket is taking off, the larger the structure, the easier it is for it to break. And then if you're in the environmental test campaign and your spacecraft is in the shaker and it breaks, that's pretty much the worst case scenario. It's you pack up and you go back and you have to build it again. And what the European Space Agency is looking at right now is figuring out a way how to to use robots to actually assemble, so deliver parts of the spacecraft or parts of whatever project piece by piece to space, and then somehow enable the assembly of the spacecraft in orbit and not on Earth. And yes, here we will definitely need a lot of very fancy, very smart robots. Yes, Mehdi.
Hello. I was wondering, how do you deal with space system and sustainability? Like, is this a method or?
Sustainability. Can you maybe elaborate a bit?
Well, for example, I know that there are so many probes in space, and some of them have lost their connection, and they are just floating in space, and it can affect our orbit or different various projects.
Yes, that is very true. So space junk, as we call it in general, is a huge problem, because first off, you keep orbits blocked, and this is the simplest problem. The more complicated problem is once you completely lost the ability to control these probes, then you risk that it accidentally slams into something else, and two objects colliding in space and generating more debris is incredibly dangerous. I think also a few years ago, the ISS was some part of the ISS was punctured because of one of these very, very small debris. And also, yeah, so this is also a huge topic in the space industry now in general, because more and more companies and institutions want to put new satellites in space, and there's not so much space left, at least useful orbits. In general, what has been established, I think roughly 10 years ago, was a general rule that for every new spacecraft that is launched into orbit, there has the manufacturer of this product is obligated to also implement a way to dispose of the spacecraft. And the most common use of disposal is to actually burn it in the Earth atmosphere. So when the probe is deemed unusable anymore, but we can still communicate with it, then the owner of the space probe, so NASA, ESA, private companies, then have to actively take the decision of deorbiting and basically destroying the spacecraft. But then also, I think right now there's studies ongoing to see just how, so when you do this for one or two spacecrafts in 5 to 10 years, maybe it's not that big of an issue. But if more and more more and more spacecraft are being destroyed in this way. How will this actually affect the atmosphere? How will this affect the people? So every action has its own consequence. And another idea that is currently being investigated by the major companies is how to more nicely dispose of it, so to say. So, for example, let's say you have your spacecraft stuck in orbit, and maybe it's not a low Earth orbit. So when it's a low Earth orbit, maybe you are lucky, and then in a few tens of years, it will get as closer and closer, and then the atmosphere just drags it, and it burns up. But if it's further away and this is not an option, then we have to figure out how to make smart service spacecraft that can actually fly to these satellites and take them out of orbit and move them somewhere else in order to be properly disposed of, or just drag them into the atmosphere and let them burn. Yes, Elisa.
And so it wouldn't be very sustainable or achievable to set like a very an auto destruction not button but command.
No, because then you, if you make it explode, then all of the pieces will just randomly float into space and most likely destroy everything that that ends up colliding with them.
I understand. It makes sense.
Good. That would have been cool if it was that easy.
Yeah, no, it would have been way too easy.
Exactly. Exactly.
So we take out technology from space just with other technology.
Mm,
I mean, satellites.
yeah. But there's still so much. So the industry, this industry is not so. I wouldn't say far advanced. So it is very advanced, but the rules are so much more different because suddenly you are in zero gravity floating around in space, and then if you want to build something to be functional there, how do you test this? How do you make sure that your robot is functioning properly in zero gravity when you can barely test it in zero gravity on Earth? So this would also be something interesting to figure out. How can we more easily test our products on Earth to be as in a way that is as close as possible to their operation in space? Also smart robots that can assemble or can help other units assemble themselves. So like you can think about it like puzzles. You send out parts of a project, and then something else has to be able to help the spacecraft assemble itself like a puzzle.
This sounds really familiar. Has it been in like a movie or just scientific articles? Because it seems very familiar. It sounds very familiar to me to send out piece by piece.
Yeah, I'm not sure if it was a movie, but it's definitely in science articles. So this is also part of the European Space Agency's plan, some sort of plan for the next decade. This is what they hope the industry is going to evolve to.
So build huge satellites by sending them by their own turns.
Yeah, in pieces, yes.
Oh,
Take, for example, how risky it was to send the James Webb Telescope. I don't know how many of you have seen the documentary. It's on Netflix, and it's absolutely mind-blowing. They basically 300 single point failures in this spacecraft alone. So with the single point failure, it's basically if this doesn't work, then that's it, end of story. And to have over 300 of them on a project that goes into space and you can't do too much about it is completely mind-blowing. And you can just imagine maybe how much more easier it would have been if they could send the telescope in pieces, and then you would have it much more safely assembled in space than to automatically perform the release of the what was it, the sails. I think this was the biggest problem when they deployed the sails to shield the mirrors from the sun.
Okay.
And where exactly can you build it in space, like on the orbit, or?
It could be on a very high orbit, for example. I assume not really a low orbit, because then you would constantly have to fight the pull of the atmosphere. So in a high orbit, then you don't have to expend fuel in order to stay in the same position. But it could be assembled anywhere. It could be assembled, I don't know, for example, if we want to have more extensive moon operations, so go back to the moon and do further activities there, you could also, for example, have the assembly in orbit. I know there's another project, it's called Project Gateway, and this is basically an initiative to build another international space station, but the one that is going to go around the moon instead. Jad?
What are the most used programming languages and computer science knowledges you use on a day-to-day basis?
On a day-to-day basis, let me think. I think the space projects that I was involved in so far were all written in C. So I learned this language in my first year of university. Then I used it for roughly 5 years at Continental, and then I moved into the space industry and I got to use the exact same thing. So this was really cool. This was a very useful. This was very useful for the transition, because I didn't have to spend months or years completely learning a new job. I had access to it instantly because I already knew what they needed. For computer science enthusiasts, I also strongly recommend that you put more emphasis on software design and not so much on learning a lot of programming languages, because when you need to use a certain programming language, if you already know the concepts behind software engineering, you will be able to learn any programming language in a couple of months. But the biggest impact that you can have is to learn how to actually design software systems, distributed software systems, in particular.
And did you learn that in university?
Yes. I was rather lucky to have been granted an Erasmus scholarship. This was also very exciting. So I only found out about it in my second year of university, and then I applied to it. There are a lot of universities throughout Europe where you can go as an exchange student, and then you learn maybe also some different, you manage to have some courses that maybe your original university doesn't provide. So for example, for me, I went to Linköping in Sweden, and the curricula was not exactly one-to-one. And if this is the case, then you can agree with your coordinating professor to somehow swap certain courses for something else. And I'm very grateful to my university coordinating professor that he allowed me to do this, because I managed to learn parallel programming. And in order to complete that course, you actually had to use Sweden's national supercomputer to write your your lab projects.
Okay, so as much as we can get from Erasmus projects, we should go for them.
Yes, exactly.
Noted that too.
You would usually get so you get a scholarship, and you can move abroad to some other country and study there. It's a fantastic opportunity to also live in another country, see another culture, and learn in see also a different how do you call it, a different way of learning. So for example, in Sweden, the way the university was working was fairly different from the way the Polytechnic was working.
Okay, well, I wasn't expecting that, but
Me neither.
and as you may know, we are approaching the end of the meets, but if there are any other questions from the public, please raise them now, or else I will have the final question asked. Or
if there's also anything else later that somebody might want to know, feel free to reach out to me, let me know, and then I can gather the information or provide the information if possible.
okay, so if there aren't any other questions, I would be pleased to ask you, Simona, to recommend us, especially because I think that half of our robotics club is in their final high school year right now. What should we do at university to continue promoting technology and therefore STEM education?
How to promote STEM education at university?
Yeah, especially the technology, the domain of technology in which you are a specialist to us.
That is a very interesting question. I think that being able to show other people how what they can achieve in their future is the biggest drive. So the moment that someone sees something that they are interested in, and they realize, yes, this is exactly also what I want to do, that is the moment that you basically won. You managed to help this person find what they are interested in pursuing in their life.
So inspire others.
Exactly. Exactly.
Okay, inspiration is a very good word for what we do. So
that's true. That's true. Keep up the good work and best of luck. And if there's anything else that I can help you with, let me know.
Well, thank you so much, and I'm really pleased that you found time in your really busy schedule, and I'm not kidding, because what you've told me, not only over the phone but on this meeting too, is very, very impressive. And I speak in the name of the club that we wish you very good luck.
Thank you.
Fingers crossed on the 7th of October.
Thank you very much. Yes, please tune in, watch us make history in Planet Defense. and hope to talk to you again soon. I need to check with the company if maybe there can be some sort of collaborations. I'll reach out to you in related to this topic.
I'll be open. I'll be here.
Perfect. Okay. All the best to everybody. Get inspired. Find what makes you very excited and what you want to do in life. Best of luck and have fun.
Thank you so much.
Thank you.
And we wish you once again good time.
Thank you. Thank you. Bye bye.